All right, so guys, what we're looking at here is a big model of the human heart. Okay, across the top we've got the base of the heart, and on the bottom we have the apex of the heart. Okay, this is the anterior surface of the heart, guys. Back here, you see all of these crazy structures. That's the posterior surface.
When you see it, what are your landmarks?
Trachea.
Breathe at your. If I see the trachea, I know it's
Posterior. Okay. Okay. Now, guys, front of the heart here. First thing we're going to look at, guys, right here and here, we got these pale-looking structures. These are your auricles. This is the right auricle. This is the left auricle. Remember, the auricles are blowout chambers that stops the atriums from popping. Okay. We open up the heart here.
Aren't you an ex-bodybuilder? Come on.
Force breaks things, don't you know that? Come on. Okay. Now guys, we're inside the heart, okay? First thing I want you to do and always do, guys, look for that thick left ventricle, okay? Now, thick left ventricle here, you can see how skinny the right one is, okay? This one's really not the problem, guys, when I use this model, but when I flip this thing over here, it confuses a lot of people. Because now the left ventricle is on the right side, okay? So you always look for that thick muscular wall. That will always tell you that that is the left ventricle. Then you know this is the right ventricle, and then you can figure out your atriums, okay? Up top here, guys, you can actually see part of the auricle, okay? And over here, that they're hollowed out chambers, okay? And the safety features for, once again, the atriums, okay? So up top here, guys, we have the left atrium, okay? And you'll notice in the walls, you got these pock marks. That represents the pectinate muscles of the atriums, okay? Pectinate muscles up here. Yeah, like a cone. Okay. Now coming down here, guys, we have the left ventricle. Okay. In the left ventricle, guys, we're going to have our AV valve. So this one here, left side. What's his nickname?
Left side?
Yep.
Left side is the
Mitral valve. Okay. So this is the mitral valve, also known as a AV valve. Okay. Bicuspid valve. And here, guys, we're going to have the chordae tendineae. Here's our papillary muscles, okay? And in the myocardium, guys, you can see it looks like kind of coral or chop meat. That's the trabeculate carni. Okay, this is all trabeculate carni muscles, okay? Over here, guys, we got the right side of the heart, right atrium, right ventricle, okay? Once again, papillary muscles, chordae tendineae. This valve here, which AV valve is this, guys, right side, tricuspid. Okay. All right. So interventricular septum, intraatrial septum up top. Okay. Now over here, guys, we got the same exact structures. Okay. We have the right atrium. We have the pectinate muscles up in right atrium, left atrium, pectinate. Not too much pectinate on that side. Okay. Auricle on this side, we don't have it here, okay? Over here, guys, once again, we walk through our AV valve. This one here, right side, is going to be tricuspid again. Here's our chordae tendineae, papillary muscles down here, trabeculate carni muscles down below, okay? Over here, left side, guys, once again, look how wide that myocardium is, trabeculate carni, papillary muscles, chordae tendineae, and that little mitral valve over here, okay? Interventricular septum here, intraatrial septum here, okay? Now, if we look at conduction, guys, of the heart, remember, we're going to start up here, superior atrium, right side. This is the SA node, okay? Here's the AV node, okay? Through here, guys, we're going to have the bundle branch or the bundle branch of His coming through here. Then we have our left and right bundle branches comes down through here. You can see the moderator bands, guys, coming off the side. Once again, they're going to innervate the papillary muscles to help protect the valves so that they don't get blown in.
How do you
Okay?
tell the difference between the moderator band and the trabeculae carne?
Trabecular carne, just muscle.
Okay.
Moderator band on here, you can see the whiteness that represents the nerve.
Okay, so that's how you would notice because you see the nerve there.
Yeah. Okay.
Okay.
So this is the nerve. Okay. So coming down, guys, we go into the apex here. You'll notice that the nerves make a bend here, and now these are the Purkinje fibers that go deep into the myocardium. Okay, and that allows, guys, it allows the stimulation to come down with no muscular contraction here until it gets to the apex, so that this can contract from the bottom up and eject the blood out. Okay. Okay. Last thing we got to do, or inside the heart, guys, right here, in a fetus, since mom's doing the breathing and the lungs aren't even active in a baby, we have an opening here. There's a window here, guys, called the foramen ovale. Okay, foramen ovale goes right through here. Blood shunts right across, guys. Deoxygenated blood and oxygenated blood just goes straight across the heart. Okay, there's usually a flap of skin that hangs down. Once the baby comes out and starts breathing on its own, the heart increases its pressure because it now turns on the pulmonary circuit, and the increase in pressure takes that flap of skin and closes that window. Okay, when it closes the window, guys, that flap of skin kind of gets sucked in a little bit into that hole, into that foramen. So in the adult, it leaves behind an indent here called the fossa ovale. Okay, this is the fossa ovale. In the fetus, it would be the foramen ovale. There would be a window there. Okay. Now, around the outside of that skin, guys, you're going to see a lip gets formed here, and that is called the limbus of the fossa ovale. Okay, so that is that donut-looking thing. Okay. Now, guys, have you ever heard of a baby being born with a hole in its heart?
Yeah.
That's the hole. Everybody has it. Okay. There can be some birth problems where maybe the flap of skin isn't long enough, so when it closes, it doesn't close off the window entirely, and you're still going to get that shunting of blood across there. Okay. Shunting of blood, guys, across there will make noise, and noises in circulation. Okay, we call that a murmur when it's located in the heart. Okay, so you can have a murmur being heard from leakage there, or you could have murmurs, guys, from the leaky valves. Okay, everybody go with that? Yeah. Okay, now let's move on to some of the blood vessels here. Okay, so guys, over here we're going to feed the right atrium. Okay, this big vein here, this is called the superior vena cava. Superior vena cava is going to drain the head, neck, upper extremities, and upper chest area. Okay. On the bottom, we're going to have the inferior vena cava. That's going to drain the lower extremities and the lower portion of your torso. All that blood, guys, goes back once again to that right atrium. Okay. Now, from the right atrium, the blood's going to go through the AV valves, goes into the right ventricles. Ventricle constricts. It's going to blow the blood, guys, out of this valve right here, which is one of our semilunar valves. This is the pulmonary valve. Okay, so the blood's going to go through the pulmonary artery or trunk, and then into the pulmonary arteries, goes to the lungs. It's going to drop off carbon dioxide and pick up what? Oxygen. Okay. Now, from the lungs, guys, it's going to come back to the left atrium through these red structures right here known as the pulmonary veins. Okay. Pulmonary veins are now bringing oxygenated blood to the left side of the heart. Okay. Goes from the left atrium. Come on.
So veins are bringing back oxygen.
Yeah. Okay. Goes to the left atrium. Goes to the left ventricle squeezes, goes through this valve here, guys, called the aortic valve, also another semilunar valve. And you'll notice, guys, here's the ascending aorta, okay? On this artery, you will notice the first two blood vessels that come off are the coronary arteries, right side and the left side, okay? It's going to feed the myocardium itself. So your heart, guys, hardest working organ, he gets the blood first, okay? Okay, so up in here, guys, we've got the ascending aorta. Here's the aortic arch going through here, okay? Now, another thing that we have in a fetus is this white band right here. In the fetus, guys, this is actually open. There's a duct in here called the ductus arteriosum, okay? Ductus arteriosum allows blood to shunt between the aorta and the pulmonary trunk here, okay? Once we're born, guys, what happens, we get vasoconstriction of the smooth muscles at each end of that ductus arteriosum, okay? It closes off and it stops the blood that was in there. It entraps the blood there. It stops blood flow. The blood in there, guys, has fibrinogen in there, so there's protein fibers. There's water in our blood. What's going to happen is the body's going to absorb the water, and the fibers that are left behind will turn this thing into a ligament. So the ductus arteriosum becomes the ligamentum arteriosum in an adult, okay? And that's what you see here. So this here and the foramen ovale are your fetal shunts in the circulatory system, okay? All right, now, what I want to point out, guys, is that in the pulmonary circuit only, heart and lungs only, you will have arteries with deoxygenated blood, so they will be blue, and the veins will contain the oxygenated blood, which will be red. That is only in the heart and lungs. Everywhere else in the body, guys, you're going to have the arteries being red and the veins being blue, okay? So like out here, guys, these are going to be what? These are arteries. Blue ones are veins. Pulmonary circuit, they're ass backwards, okay? So if I tag something like in the lung there, if I tag something red, you're going to give me pulmonary vein, okay? And if I tag it blue, pulmonary artery. It's going to be ass backwards, okay?
But that's the only exception. So
That's the only exception. Yep. Okay. Good.
The coronary arteries in front of
These out here, yeah, we'll hit that tomorrow for circulation.